Hey everyone, so in this video, we're gonna walk through a couple time value of money problems. So in this first problem here, we have the amount a person would have to deposit today at 7% interest to have $3,000 5 years from now. So when you're working through these problems, you wanna ask yourself two questions. The first question is, are we dealing with a present value or a future value situation? And then the second question you want to ask yourself is, are we dealing with a lump sum or an annuity? So a lump sum would be just like a total dollar amount at a certain period of time, whereas annuity would be a fixed amount, let's say over 5 years per year. So in the question, you're going to see language that's going to give it some hints on whether we're dealing with these situations. So when I read this first question, sometimes the questions will just kind of flat out tell you this is a future value or present value situation, but sometimes it won't. So we do need to kind of pick it out from the verbiage. So it says the amount a person would have to deposit today. So we know that today is the present. So this is a present value situation. So next, we want to look for information, is this a lump sum or an annuity? So it says at 7% interest to have $3,000 5 years from now. So it doesn't really say anything about per year or anything. So this is actually a lump sum situation. So once we have those two things identified, then we would go to, in the homework, what I've done is I've set it up so you can kind of see the general format of each problem. So we know for this first question, this is a present value and a lump sum amount. So if we look here, the general format of this problem is going to be the desired future value times the present value factor. You say use present value lump sum here. So if I go back to my slides here, I brought in that general format. Well, with this general format, we are going to be given half of it already. And that's going to be our desired future value of $3,000. So we'll just bring our $3,000 down here and we'll say that's going to have to be multiplied by some present value factor. Well, that present value factor needs to come from the time value of money table. So I'm going to go back to the homework assignment here, and you can see that I have the 4 different tables. So I need to find the present value lump sum link. So I'm going to go ahead and click on this, and I'm going to bring up the table here. And so the way the table is organized is we have our periods running in our rows, and then we have our interest rate or rate per period. A lot of these problems, you're going to have to go to the second page. So this particular problem was 5 years and 7%. So I'm going to go ahead and scroll down here. The periods switches over to the right-hand side when you're on this next page here. So we have, here's our 5 periods. And then I'm going to go across to 7%. So our present value factor is going to be 0.71299. So go back to my slides here, and I'm going to go ahead and bring that down. So now we're just going to do $3,000 times 0.71299, and that gives us $2,138.97. So this is how much we would have to deposit today in order to have $3,000 5 years from now at 7% interest. Let's go ahead and work through the next one. So the next one says the future value of $2,000 saved each year for 15 years at 5%. So again, we have our questions again. And so we could see here that this one actually explicitly tells us this is the future value. So we'll go ahead and circle the future value here. And now we're looking for verbiage, whether this is a lump sum or annuity. And I could actually see that it's saying the future value of $2,000 saved each year. So this each year here is important, and this tells us that this is an annuity. So now I'm going to go ahead and bring down that general format. I'm not going to go back to the homework this time. So all 4 of the general format formulas for these time value money problems are in the homework. So for this one, our general format is just the annual amount saved times the future value annuity factor. So the FVA, now the A in here is the annuity factor. So I'm going to go ahead and bring down the $2,000 from the problem for the annual amount saved. And we just need to get our future value annuity factor from the table. So let's go back to our assignment here. And so I am looking for future value annuity. So we could see the second bullet here is future value for an annuity. So I'm going to go ahead and click on that link. And from the problem, it was 15 years and 5%. So again, we're on the second page here. We'll come down to 15. And then I'm going to go across all the way here to the 5%. And we got 21.57856. So going back to our slides, we're going to go ahead and bring in our future value annuity factor. And we'll just take $2,000 times 21.57856. And we get $43,157.12. So let's get saving. We could see that that really adds up, $2,000 a year for 15 years at 5%. All right, let's move on to the next one. So the next one is the future value of $1,000 10 years from now at 7% interest. So again, this told us straight up that we're dealing with future value. So let's circle the future value. And now it says the future value of $1,000 10 years from now. So we can assume in 10 years from now, what's going to be that lump sum amount that we have at the end of the time period. You don't see anything like per year or each year, anything like that that gives us any clue that we're dealing with an annuity. So this is a lump sum. And so you'll see that this is pretty consistent. We're going to bring down our general format, and our general format is going to be the amount deposited times the future value factor. Let's bring down the 1,000 from our problem. And so we're going to do 1,000 times the future value factor. And now we need to go get that factor from the time value table. So we're going to go ahead and go to our homework here. And we know that we're dealing with a future value lump sum amount. So that's going to be this first one. And this one was 10 years and 7%. So I come down to 10 and go across to 7, and it's 1.96715. So we're going to go ahead and go back to the slides. We're going to plug in our future value factor. And we're going to take $1,000 times 1.96715, and we get $1,967.15. All right, let's wrap up this video and do one more problem. So in this problem, it says the amount a person would have to deposit today to be able to take out $2,500 a year for 15 years from an account earning 6%. So this one's a little bit more detailed and we have to digest the information a little bit more, but it says the amount a person would have to deposit today. So we have that key word again, today, so we know that this is a present value situation. And so when I look at the second half of the problem, it says to be able to take out $2,500 a year. So when we see that a year, we know that we're dealing with an annuity. We're going to bring down our general format. And so our general format for this one is going to be the annual withdrawal times our present value annuity factor. And we have our $2,500. So let's go ahead and bring that down to our problem. So we have $2,500 times the present value annuity factor. So we have to go get that factor now from our table. So we're going to come to our homework and we're going to look for the last option here, which is present value annuity. So that was here. We're going to click on that table. In the problem, it was 15 years and 6%. So I'm going to come down to my 15-year periods and across to our 6%. And we have 9.71225. So coming back to the slides, let's plug in our factor. So we have $2,500 times our 9.71225, and that gives us $24,280.63. So as you can see, working through these time value of money problems is actually not that difficult once you break it down into its smaller parts. And you first want to identify if you're dealing with a present value or future value situation, and whether you're dealing with a lump sum or annuity. And so once you have those two pieces of information, it's really a very generalized format on how you're going to solve your problem. Half of the information will be given to you on the left side of the problem, and then we just need to use our time value of money tables to get our factors. I hope this helps you out on this homework assignment, and please don't hesitate to reach out if you have any other questions.